Hey guys, today we're looking at 5.3, which is going to talk about our sum and difference identities for cosine. So, sum means adding, difference means subtracting. And so, if we're looking at our sum identity, that means I have the cosine of A plus B, so two different angles that I'm adding together. And that would equal the cosine of A times the cosine of B minus the sine of A times the sine of B. And then if I have my difference, cosine of A minus B, that would equal the cosine of A cosine of B plus the sine of A sine of B. So let's look at a couple of examples and see what this would look like. This is really helpful if we're looking at angles that aren't necessarily on our unit circle and we're trying to figure out what they would equal. So for example, I've got 15 degrees right here. 15 degrees does not fall on my unit circle, but I could use two angles that do fall on my unit circle to help me figure out what the cosine of 15 degrees would be. So the first thing that I think of is that 45 degrees minus 30 degrees gets me to that 15 degrees that I'm looking at right there. So if I'm subtracting them, that means I'm using my difference identity right there. So that means that I would have the cosine of A, cosine of B, plus the sine of A, sine of B. And 45 degrees would be my A, 30 degrees would be my B. So I'm just going to plug that in. I'm going to have the cosine of 45 degrees, the cosine of 30 degrees, plus the sine of 45 degrees, and the sine of 30 degrees. Then I'm going to use my unit circle to help me figure out what those values are. So remember, your cosine is the x part of your point. The sine is the y part of your point. So the cosine of 45 degrees would be the square root of 2 over 2. And the cosine of 30 degrees would be the square root of 3 over 2 plus the sine of 45 degrees is also square root of 2 over 2, and the sine of 30 degrees is 1/2. And then I'm just going to simplify that, multiply it together, and then use my algebra skills and clean it up a little bit. So if I have the square root of 2 over 2 times the square root of 3 over 2, I'm just going to multiply across the top, multiply across the bottom, so I get the square root of 6 over 4. Plus, over here, square root of 2 over 2 times 1/2 would be the square root of 2 over 4. And since they have the same denominator, I can write them as one big fraction with that denominator of 4. So the square root of 6 plus the square root of 2. From here, you would need to see if you can break down that square root of 6, which I can't. See if I can break down that square root of 2, which I also can't break down. So I'm just going to leave it like that, and that's my answer. I can't take anything out of that square root of 6 or out of that square root of 2. So there we go. Let's look at another one, but this time we're going to do it in radians, because remember, degrees is not the only way you can measure an angle. This is where sometimes it does get a little bit trickier to figure out what you're either adding or subtracting. So if I'm looking at 5 pi over 12, when I'm trying to think of what I could add or subtract to get there, I'm going to think about what numbers add up to 5 that are also maybe factors of 12 so that I could have fractions that are maybe going to simplify to something that's on the unit circle. So remember our unit circle, we have like pi over 6, pi over 4, pi over 3, pi over 2. I don't have anything that's pi over 12, so I need something that's going to simplify. So the first thing that comes to mind to me is 3 plus 2. So I'm going to do, instead of 5 pi, 3 pi over 12 plus 2 pi over 12. 3 pi over 12 simplifies down to pi over 4, and 2 pi over 12 simplifies down to pi over 6. And both of those are on my unit circle, and so that's going to work out for me. This time I'm adding, which means I'm going to use my sum identity over here. So when I look at that, that's going to be the cosine of A, cosine of B, minus sine of A, sine of B. Okay, I'm going to plug that in. So the cosine of pi over 4, cosine of pi over 6, minus sine of pi over 4, sine of pi over 6. The cosine of pi over 4 is the square root of 2 over 2. The cosine of pi over 6 is the square root of 3 over 2 minus the sine of pi over 4 is the square root of 2 over 2, and the sine of pi over 6 is the 1/2. Looks pretty similar to what we just did up there, except for now we're subtracting them. Okay, I'm going to keep simplifying, so I get the square root of 6 over 4 when I multiply together the first two fractions, minus the square root of 2 over 4 when I multiply the second two fractions together. There we go. And so I can write it all together as the square root of 6 minus the square root of 2 all over 4. And something to also be aware of when it says find the exact answer, you're going to leave it like that. You're not going to type it in and try and get a rounded decimal in a calculator or anything. Exact answer means radicals and all. No rounded decimals here. If I look at example 3, this one's kind of going the other way around. It's already in that cosine times cosine minus sine times sine, that split up version, and I need to go backwards and figure out if I'm using the sum, cosine of a plus b, or the difference, cosine of a minus b, and see if I can simplify it. So what I'm going to pay attention to is what's happening in between my two terms. Since I'm subtracting right here, that's going to match with my sum identity. So that means I have the cosine of a plus b. Okay, I've got a and b, a and b. So my a value is 87 degrees, my b value is 93 degrees. So the cosine of 87 degrees plus 93 degrees. When I add those together, I end up with a cosine of 180 degrees. And 180 degrees is on my unit circle. 180 degrees is over in the negative side of my x-axis. 180 degrees, if I'm looking for the cosine of that, it's going to be -1. So my answer here would be -1. Okay, the next thing we're going to look at here is our cofunction identities. Remember we did talk about these back in Unit 1. I'm going to touch on them here again because they are kind of sort of similar to my sum and difference identities. And so sometimes you can get kind of confused on when to use one versus the other, because notice we are talking about like 90 degrees minus theta. So we got to be a little careful here when we're talking about these. So remember, if we're talking about cosine, that's paired with sine. So my first one's right here. If I have the cosine of 90 degrees minus theta, that's the same thing as the sine of theta. And the other way around, if I have the sine of 90 degrees minus theta, that's equal to the cosine of theta. Tangent and cotangent are paired together with the same relationship, and secant and cosecant are paired together with the same relationship. And then when we talked about these back in Unit 1, we were only using degrees. But now we know what radians are because we learned about those in Chapter 3. So we need to make sure that you remember that 90 degrees is the same thing as pi over 2 radians. So sometimes we may be in degrees, sometimes we may be in radians. So you got to make sure you're paying attention to that. Remember, degrees is when you have a degree sign. If there's no degree sign, then it's a radians. So if I look right here, I can see that I do have a degree sign, tangent of 25 degrees. And so my goal here is to figure out how I can solve this equation for either theta or x, this time theta, to find one value of theta that satisfies the following. In order to solve this, I need it to be a cotangent equals a cotangent, or a tangent equals a tangent, so that I can cancel those out. And so that's where my cofunction identities are going to be helpful. I can, on this left-hand side, rewrite this using my cofunction identity. The cotangent of theta is the same thing as the tangent of 90 degrees minus theta. Okay, once I do that, I've got a tangent equals a tangent, and so I can just look at what was inside the tangents. 90 degrees minus theta has to equal 25 degrees because it's a tangent of something equaling a tangent of something. If two tangents equal each other, the inside parts have to equal each other. From here, I'm going to subtract 90 degrees from both sides. So I get negative theta is equal to negative 65 degrees. And then divide both sides by -1 to get theta is equal to 65 degrees. Okay, let's look at another one. Just make sure we remember how to do this. This time I have a sine and a cosine. And once again, it is the cosine of negative 30 degrees. So we're still in degrees. So I'm going to take this sine of theta and I'm going to use my cofunction identity and rewrite it so that's the cosine of 90 degrees minus theta. So the cosine of 90 degrees minus theta is equal to the cosine of negative 30 degrees. And then I can just look at the inside parts. 90 degrees minus theta has to equal negative 30 degrees. I'm going to subtract 90 degrees from both sides. So negative theta equals negative 120 degrees. And divide both sides by negative 1. So theta equals 120 degrees. And like I was saying, degrees aren't the only thing. And if you look at example 6, I don't see any degree signs. So now we are looking at radians. No degree sign means radians. So instead of 90 degrees, this is where I would be using my pi over 2 when I work through this problem. So I've got cosecant and secant. So I'm going to rewrite the secant of x as a cosecant. So this side is still cosecant of 3 pi over 4. But now my right side is going to be cosecant of, and it's going to be pi over 2 minus x because we're in radians. Same idea as what we were doing with example 4 and example 5. I can just look at the inside of the cosecants. So 3 pi over 4 has to equal pi over 2 minus x. I'm going to subtract pi over 2 from both sides. I have 3 pi over 4 minus pi over 2. That's going to give me pi over 4 is equal to negative x. Remember, we need a common denominator, so 3 pi over 4 minus pi over 2. I can write that as 3 pi over 4 minus 2 pi over 4. And so that's how I'm getting pi over 4. 3 pi minus 2 pi is 1 pi. And then I just need to divide by negative 1. So x is equal to negative pi over 4. And then there is a little note here. It does says because trigonometric or circular functions are periodic, the solutions in the examples that we've done are not unique. We are finding one value of theta or x, but there are infinitely many possibilities. Remember, you can just add 360 degrees or add 2 pi, and you will keep finding more answers because they keep going around the unit circle, circular functions, or they're periodic. They keep following that wave on the graph that we talked about for sine and cosine, or our different graph patterns that we talked about when we were looking in chapter 4. So just keep that in mind. We are only finding one of the possible answers here, so that's why our directions say find one value of theta or x. Now, the reason that I've paired these together, like I said, is it's tricky to make sure you're paying attention and make sure that you're using the proper identity, and these specifically get a little messy. If I'm looking at example 7, you might automatically think, oh, this kind of looks like a cofunction identity. But if I'm looking at cosine of 180 degrees minus theta, all of my cofunctions are 90 degrees, not 180 degrees. So you have to be very, very careful that you're paying attention when to use a cofunction identity and when to use a sum or difference identity. Since this one has 180 degrees, we cannot use a cofunction. So when it says to write this as a trig function of theta alone, this is where we've got to use a difference identity. So remember, that's the cosine of A, cosine of B, plus sine of A, sine of B, where A is going to be that 180 degrees and B is going to be theta. So B is still going to be an unknown there, which we are trying to write it as a trig function of theta alone. So we're still going to have theta in our answer here. We're not going to get down to only numbers. So I'm going to do the cosine of 180 degrees, the cosine of theta, plus the sine of 180 degrees sine of theta. And lucky for us, 180 degrees does fall on our unit circle. So I can go ahead and figure out what those are. Cosine of 180 degrees, remember that's the negative part of our x-axis. So our cosine of 180 degrees would be -1. And then we're still going to have our cosine theta plus, and then our sine of 180 degrees is 0. And then we still have our sine of theta. Now, if I have 0 times anything, that's just going to be 0. So that entire second part, the plus 0 times sine theta, is just going to go away. So I'm going to have negative cosine theta, and that's my answer. That's all I'm left with. And we've got one more problem we're going to look at. Example 8 says, suppose that sine of s is equal to 3/5 and cosine of t is equal to -12/13. Both s and t are in quadrant 2. Find cosine of s plus t. So this is our sum formula. So that's going to be the cosine of s, cosine of t, then minus the sine of s, sine of t. And I do know some things that we can go ahead and plug in. Like I know the sine of s, so I can go ahead and plug that in right here. The sine of s is 3/5. And I know my cosine of t. I can plug that in over here. But you'll notice we're missing some parts. I don't know my cosine of s, and I don't know my sine of t. Now it does tell us that both angles are in quadrant 2. And so we're going to have to use some of our previous knowledge that we talked about in some previous units, some of the things that you've learned in geometry. Specifically, we're going to have to use our SOHCAHTOA to help us out here to find our missing values. If we're talking about being in quadrant 2, I'm going to draw my coordinate grid. And quadrant 2, remember, is in the upper left corner. So I'm going to put angle S, we'll start with up there, and make a triangle and use my SOHCAHTOA to find that missing part. So if I'm looking at S, we have sine of S, so that's going to use SO over here. So my opposite and my hypotenuse, my opposite would be the 3 going up and down across from the S, and my hypotenuse would be my diagonal, my 5. To find my missing side, I'm going to have to use my Pythagorean theorem. A squared plus b squared equals c squared. So 3 squared plus b squared is going to equal 5 squared. Remember, your hypotenuse always has to be c. So 9 plus b squared is equal to 25. Subtract 9 from both sides. So b squared equals 16. And b is either plus or minus 4. Since we're back in quadrant 2, negative on the x-axis, that's going to be -4. Now over here, I need to find the cosine of s. Ooh. So now I'm going to use ka from SOHCAHTOA to help me find that. My adjacent over my hypotenuse would be -4/5. And I'm going to do a similar thing, make a triangle for t, and find that value. So once again, t is in quadrant 2, so it's going to be up here in the top left. Put t. This time I know the cosine though, so remember that's ka, that's my adjacent and my hypotenuse. So I'm going to put a -12 here, because remember we're going on the negative x direction, and a 13 for the hypotenuse. Remember the diagonal of the hypotenuse is always positive. And once again, I'm going to use my Pythagorean theorem to help me find my missing side. So a squared plus a -12 squared is equal to c squared. So a squared plus 144 is equal to, sorry, that shouldn't be c squared, that should be that 13 squared, so 169. Subtract 144, and I get that a squared is equal to 25. So a is going to be plus or minus 5. We are going up, so it's going to be a positive 5. I need to find the sine of t, so I'm going to use my so, and so I'm going to do 5 over 13. Opposite over hypotenuse. And then from there, I just need to simplify my fractions over here. So if I have -4/5 times -12/13, multiply across the top and multiply across the bottom, -4 times -12 is going to give me a positive 48. 5 times 13 is going to give me 65, minus, then my fraction over here, 3 times 5 is 15, 5 times 13 is 65, and then I just subtract across the top. So 48 minus 15 is 33 over 65. And there's my answer. So this is how you can use your sum and difference identities, and then a little refresher on your cofunction identities. Remember also that these are identities that you can use when you're verifying trig functions too. So we did that in 5.2, and still going to be using that throughout the rest of this unit. So these are now fair game when you're verifying identities. Some more tools in your tool belt. So make sure you get started on your assignment that goes with this set of notes. Let me know if you have any questions, and y'all have a good day.